In this video, I'm going to talk about another type of advanced MPLS Layer 3 VPN managed CE router services. First, we should know that what is the managed CE router services, and after that we can talk about how we can configure this type of advanced VPN. The first thing that I'm going to talk about that is, in some cases, we are supporting our customers in providers. For example, we are working in one service provider and we want to support the customer's edge routers. For example, we can manage the configuration of the configuration of the VPN or some other features in the CE routers, or maybe we give the customers some services, for example, monitoring the status of the CE routers, or monitoring the health of the CE routers, or some other things about the CE routers. Because of that, in service provider, we have one or some network management system, or NMS, that we can use this NMS to configure, to monitor, or maybe sometimes troubleshoot the CE routers. Because of that, we need to have connectivity between these, for example, NMS and the CE routers R5, R6, and R9. Because of that, we need to give the, for example, this site, the NMS site, the connectivity, the reachability to the one IP address in the CE routers, for example, one loopback IP address on the CE routers. We don't want to inject all of the IP addresses, all of the networks inside the site of every customer to the, for example, NMS VRF. But we only want to inject only one loopback IP address, one IP address from the CE routers to the server one. Let me to talk about with another view about this feature. You know that until now, when we are advertising the routes of one VRF to the, for example, other VRFs, we set or we assign route target export of that VRF to the VPN v4 we are creating from the addresses of that VRF. For example, when you are advertising 192.168.10/24, okay, as you know, we are creating the VPN v4, for example, using 65,000 column 1. This is the VPN v4, and also we are using the RT export of this VRF beside of the, for example, VPN v4 we are advertising. This is the VPN v4, and you know that with RT export, other VRFs can understand that this update should be injected to which VRF. Okay, you learn about the configuration of the RT export or some other things about this. But you know that if we have multiple addresses in the VRF, for example, customer A1, all of these addresses can be sent with only the same RT export. For example, assume that here we have another IP address, for example, 192.168.20. You know that in normal cases, when we are assigning the RT export to this VRF, all of the addresses of this VRF should be same with same RT. For example, 192.168.20/24. Okay, when converted to the VPN v4, again should be same with the same RT export that we set for the 192.168.10/24. This is good in most cases, but in some cases we don't want to set the RT export for all of the IP addresses, all of the network addresses in the VRF exactly same. For example, I need to send the 192.168.10 VPN v4 with the RT export of 65,000 colon 1 and 65,000 colon 1. This is only an example. I will show you the detail. And another addresses with another, for example, RT export 65,000 colon 2. Okay, this means that we need a feature that with that feature can send the routes of one VRF with different RT export, because we need to inject the addresses in different VRFs. Okay, because of that we need to use a different RT export. Until now, when we configured RT export for one, or RT road target export for one VRF, that road target should be used for all of the addresses inside that VRF. Because of that, this is in most cases can give us the function that we need, but in some cases we need to use different RT export for different addresses in one VRF. For example, in this scenario, I need to import only one of the IP addresses residing on the router 5 to this VRF, to NMS VRF, and I don't want to inject another addresses in, for example, one VRF to the NMS VRF. Let me to show you how we can solve the problem, how we can set or send the different RT export for addresses in one VRF, and after that we can talk about the managed C router services. Look at here, managed C router services means we are giving this feature, this function, these services to the customers that we can from the NMS, this is our VRF in the service provider, and we can give the our customers the service of the monitoring the health of the C routers, monitoring the function of the C routers, or maybe, for example, configuring some features in the C routers. Because of that, we need to have reachability to the C routers with only one IP address. For example, a loopback on the router 5. I don't want to inject all of the addresses in the customer A site 1 or customer B site 1 to the NMS VRF. I need only one of the IP addresses residing on the R5 to give this managed CE services, and because of that, here we need to assign different RTs to the addresses inside this VRF. For example, for 192.168.10/24, I need to give the RT that is suitable for advertising this address to the customer A site 2. But for another IP address residing on the R5, I'm going to use a different RT for injecting that different RT into the NMS VRF. Let me to show you how we can solve the problem, how we can configure this type of scenario. This gives you one extra ability to configure advanced MPLS VPNs. And also, because I configured this scenario before in the service provider, we have exactly the same scenario. The configuration is completed previously, and only we need to configure VRF. Let me to show you first let me to reviewing the scenario. In this scenario, as you can see, we have three customers: customer A, customer B, customer C. Customer A has 2 sites, customer B also has 2 sites, and also customer C also has 2 sites, and we need to have reachability between customer A site 1 and A site 2, B site 1 and B site 2, and C site 1 and C site 2. This means that we are using simple VPNs for these 3 customers. And finally, we need to import only one IP address residing on the router 5, router 6, router 9, router 7, router 8, router 10 to the VRF of the NMS. I will show you how we can configure it. First, let me reviewing the configuration of the service provider. Look at here. I configured the service provider before because the configuration exactly same as the previous video, and because of that, I configured it before in the router 1. If you check, you can see that we have show BGP VPN v4 unicast all summary. Okay, we have neighborship with the router 11 because router 11 is our route reflector, and also in router 4, if you want, you can check show BGP VPN v4 unicast all. Okay, unicast all summary. Again, as you can see, we have a neighborship between the router 4 and router 11, and if you want, you can check for example the LDP neighborship in R1, show MPLS LDP neighbor. We have neighborship with router 2, it's okay, and also in router 2 for example we can use the show MPLS LDP neighbor. Here we have 3 neighborship with router 1, with router 11, and with router for example 3, it's okay. And also in router 3, let me check the router 3, show MPLS LDP neighbor. We have neighborship with router 2 with router 4 and with router 11. It's okay. And finally in router 4, if you want, you can check show MPLS LDP neighbor. We have neighborship, LDP neighborship with router 3. Now we need to first design the RDs and RTs for these VRFs, and after that configuring this VRFs. Let me first configure